I'm Adam Pennington. As of very recently, I now lead MITRE ATT&CK. If you haven't heard of MITRE, we're a not-for-profit that's been around for about 60 years, who primarily supports the U.S. federal government, but we do work in the public interest as well for things like MITRE ATT&CK. For the last 10 years, when I'm not working on attack, my main research area has actually been deception. So it's nice to be able to sort of bring those two areas together today. I'm going to go through a couple different segments of this. I'm going to start off by talking about classic deception and some of what people mean today by cyber deception. I'm going to cover some traditional deception planning and get into some of the attack basics I'm going to be using for the rest of the talk. Not going to have a lot of Attack 101. I know a lot of the other presentations I've talked about attack over the last week. I'm going to go into a methodology for doing intelligence-driven cyber deception planning, where I'm going to leverage attack to actually plan out cyber deception and then hit on some final takeaways. So just to get everyone on the same page, and we often mean various euphemisms when we say deception in the cyberspace. So I wanted to start off with the straight-up dictionary definition of deception. Deception is the act of causing someone to accept as true or valid what is false or invalid. It's the act of getting someone to believe a lie. It's not a new concept either. So I promise there are no Sun Tzu quotes in this presentation, but it is something that, going back all the way to the day of Sun Tzu, is something that's come up in warfare for both offense and defense. A lot of really interesting things in literature came out of deception being leveraged in World War II. Everything from the British double cross system, the man who never was, Operation Mincemeat, just a wealth of different ways that deception was used against different adversaries. And during the Cold War, a lot of maturity came to deception, where we had a lot of more formalized deception planning, literature, and other ways that it just became into its own as a doctrine. Deception is not that new in the cyber realm either. Back in the 80s, we had the cuckoo's egg. So this book published by Cliff Stoll, one of the things it talks about is an adversary being led into a honeypot. Interesting tidbit, one of the places, according to the cuckoo's egg, that the actor broke into was actually MITRE. So we do have a role here, at least a little bit. The HoneyNet project came out in the late 90s, and this has been a great resource for anyone doing deception work in terms of open source tools they put out, different presentations, white papers, and just loads of resources that go back the last 21 years. And it's become a growing product space. We're seeing a lot more people sort of build and sell technologies in this space using specifically the term cyber deception. Most of what's out there today, I would divide into focusing on two different deception goals. The first is deception for detection. This is the idea that we want to catch an adversary. We've got something living in our network or living facing the internet that we want an adversary to touch and find out that they're there. So, terminology for this is often things like honeypots, honey tokens, honey users, lots of honey in this space. Bigger and maybe more long-lived, we have things like deception for intelligence gathering. So this is the idea that we actually want to gain intel on an adversary. We want to keep them operating. We want to know more about them. And we use some of the same terminology and a little bit in some different things too. So we've got everything from honeypots, honey nets, where we've got multiple systems stitched together to keep an adversary occupied. And a lot of people have gotten sick of the honey terminology and switched to just deception environments. Across solving both of these goals, there are some frequent problems that I've seen, though, in the space. So one frequent problem is that of mismatched visibility. We see capabilities that are not where the adversary is looking. So, say we've got a capability that can only be found by an adversary that's doing port scanning. If we have an adversary that finds all of their targets inside a network using Active Directory, looking around through built-in stuff, they're not going to find this capability. And so that's a problem. If they can't find it, they can't be deceived. We also see issues with mismatched expectations, so capabilities that don't look like what an adversary seems to expect. So, say we've got a capability that's spinning up a system right before an adversary's on it. It's got a single local account where the password was created just before the adversary got on the system. We have an adversary that expects and looks for many well-established domain accounts. They're not going to probably like that, and a decent chance they're going to bug out when they see that environment. So we've been doing deception for thousands of years. What's going wrong that we've got some of these sort of simple errors going on in the cyber realm? I postulate that a lot of it is coming from mirror imaging. So mirror imaging is a very familiar cognitive trap in the intelligence space. I said no Sun Tzu quotes, but I figure threat intelligence conference, Richard's here is okay. So the problem is saying, well, if I was an adversary, I'd look for blank. Or if I was an adversary, the way I'd find the next system is something. So we aren't our adversaries. And so thinking that we've got the exact same image as our adversaries can lead to dangerous assumptions. Our adversaries aren't the same culture as us. They don't have the same needs as us. They don't have the same restrictions as us. And so oftentimes our assumptions on what we would do if we were an adversary are wrong. So in traditional deception planning, we go through processes just like other areas of threat intelligence to try to break out of some of these traps. So before we get to doing some sort of deception, actually implementing it and running it, the absolute first step is to research our adversary. We want to know our adversary's preconceptions, expectations, and reactions. Even as we design a deception, we don't start by just saying, here's the thing. We start by developing a cover story. We determine what pieces of our deception need to be hidden, what actually needs to be created and revealed to an adversary, and go through a number of steps before we actually get to deploying the deception, running it, and putting an adversary in it. So I'm going to be talking about trying to apply this traditional deception methodology to cyber deception. So this traditional deception planning is a very intelligence-driven process. And we can apply some very similar process to cyber deception. There's no reason that it needs to be a very different space. One thing though is that we likely won't know the preconceptions and expectations of our adversaries directly, unless we're lucky enough to have an adversary that goes out there on Twitter and says, when I break into a system this week, I think there's going to be 1,000 computers and maybe 1,500 users. NetView is going to work, and really hoping not to find a virtual machine. We don't get that. We're not that lucky as defenders in most cases, and so we're going to have to be inferring those preconceptions and expectations for behavior. And so we need to build up knowledge of how adversaries behave. And that's how I'm going to be leveraging ATT&CK through the rest of this talk. So I'm not going to be doing a big introduction to ATT&CK, like I said, since been covered quite a bit this past week. But just getting into some basics. ATT&CK is a knowledge base of adversary behaviors. It is a threat intelligence-driven framework made up of behaviors that real adversaries have done in the wild. It's organized first into tactics. These are the columns across the top and what we normally refer to as the attack matrix. And these are the adversary's technical goals. So things like initial access, defense evasion, impact, broad technical goals. Underneath each of these technical goals, we have the individual cells. And these are techniques. These are how the goals are actually achieved by the adversary. So instead of initial access, we have something like spear phishing attachment. Instead of impact, we have something like data destruction. Behind each of these techniques, if you're used to tactics techniques, we've also got procedures. Procedures are the specific technique implementations that real adversaries have done And the information that's in here in attack has all coming from open source, freely available threat intelligence reporting. So instead of spear phishing attachment, we have something like APT12 has sent emails with malicious Office documents. So a lot more specific implementations of a technique. So now we're going to use those tools, the traditional cyber deception planning and leveraging attack for cyber threat intelligence portion of it to do some planning of cyber operations. So I'm going to be going through a intelligence-driven cyber deception planning process. And this is very closely modeled after the Barton-Whaley process that I showed earlier in the slides. We do have a difference here. So I've taken out some of the intelligence or some of the deception-specific jargon from here, but there's also a step 0. Most traditional deception planning, especially that coming out of the Cold War, assumes we know who the adversary is. And there's an assumption that we have some specific adversaries, a starting point that we're planning this around. Well, in our realm, as defenders, we might have dozens of adversaries that we're concerned with. And so we need to start out figuring out who it is we want to prioritize on before we work with intelligence on them. So once we've determined who our priorities are, we're going to build up an adversary profile based on threat intelligence. We're going to develop a cover story that we're going to be telling to that adversary. We're going to determine what information needs to be hidden and revealed to the adversary to reinforce that cover. Then we get to the point where we can actually design and build out that technical capability, deploy it, gather intelligence, and then use that intelligence to reinforce and start over again. So to start with, we need to determine who our priority adversaries are. And how you do this is going to depend a lot on your own organization and concerns. So it could be something as simple as an adversary who targets you regularly. If you've got some adversary that every 6 weeks, like clockwork, spear phishes you, might be a good person to prioritize. You're going to have opportunities in the future. Could be an adversary who's targeted other places like you. They've broken into every other company in your sector. Could be an adversary who keeps you up at night. Maybe it's someone who you're convinced would evade your current defenses. So it's somebody that you really want to move away from other things in your network. It could also be based on intelligence gaps. Could be an adversary you don't know much about. Now, it doesn't necessarily need to be a single group either. It could be a class of adversaries you're pulling together, a specific country. Yeah, and so this is going to be determined completely on your own situation. But once you've prioritized a specific adversary or group of adversaries, we're going to start building an adversary profile based on threat intelligence. And here's where I'm going to start using attack. We're going to start by building up attack techniques used by that adversary or group of adversaries. Everything in this talk today, I'm going to be leveraging the information in attacks group and software pages. Since it's open source, freely available, so I can use it here today. And so this information is coming directly from open source threat intel reporting. Katie Nichols and myself gave a presentation at last year's first Cyber Threat Intelligence Conference, where we talked about some of the biases and potential issues with leveraging this information, but it's still very useful intelligence. You can use your own open source reporting. There's limited numbers of reports the attack team is able to get to and map and add to this corpus. So, bring into it what it is you're able to actually find on your own. Use the data you're actually paying for, so data from commercial threat intelligence providers. And then finally, absolutely supplement with your own threat intelligence, whether it's coming from previous deception operations, things you're observing. Use whatever you've got to start building up a profile. If you're working with things that aren't already in the attack groups and software pages, you're probably going to have to go through a process that's something like what we do to add that intelligence. And that's going through textual reports, identifying behaviors in that report, and then going through and mapping those out to different attack techniques so that we can build up this profile. Again, at first CTI 2019, Katie and I taught a workshop showing people how they can do a lot of this, as well as other things using attack with threat intelligence. And then a couple months ago, we made that freely available online. So if this something you want to be doing with your intelligence, we've put out some of the resources to be able to do it. So say I've decided that Turla keeps me up at night. So they're good. I think they might be able to overmatch my defenses. And I've also got some intelligence gaps around them. So if I'm just working off of the threats and groups information in attack, I have things that I know that they do, but I suspect that this might be missing things that they're doing. So I see it as an intelligence gap. But so I talked about doing preconceptions and expectations for an adversary, and this is just behaviors. So as we go from techniques to preconceptions and expectations, we're going to have to do some inference on what the adversary may expect based on their technique use. This absolutely introduces a risk of bias as we apply our own interpretation of why an adversary is doing specific techniques. But so we need to do this very carefully, but we are, like I said earlier, unlikely to have that direct intelligence of the adversary tweeting out about what they expect on our system. So say we have an adversary who uses browser bookmark discovery. What sorts of things can we potentially infer from that? Well, we might be able to infer that the adversary expects a browser, at least in some intrusions that they're operating in. We might be able to infer that the adversary expects that the browser has bookmarks. Why would they be collecting them otherwise? And if we do have an adversary that's doing this, an adversary that's looking for bookmarks is probably expecting an interactive user to be on that end system. Now, say we find out something like, the adversary, they go in there, they collect bookmarks, they don't find any, and they bug out. That could be a very good reinforcing hint that these are the expectations of the adversary. Similar to that, we have a technique like virtualization sandbox evasion. In a lot of cases, the implementation of this technique is that we have adversaries running code or processes where if they see a virtual machine, their code exits or they end the intrusion. And so from that kind of behavior, we might be able to infer that the adversary expects not to be in a virtual machine. And we can probably infer from that that the adversary believes that a virtual machine might be bad. Why would they be ending the intrusion otherwise? And so this is a process we're going to be using throughout the rest of this process in order to look at what it appears that our adversary's preconceptions and expectations are. Once we've built up our threat intel profile, it's time to start developing a cover story. So a cover story is not something we get to tell to an adversary in most cases. It's something that we fit the rest of our operation into and stay consistent with. It's what the target of the deception should perceive and believe after they've seen the other evidence around it. And so quoting from Kristen Heckman in Cyber Deception, Denial, and Counter Deception, generally the most convincing cover stories are based on what the opponent already believes and wants to believe. And so by reinforcing these expectations with the cover story, we can help the adversary be comfortable with the other elements of the cover story. And so we're going to leverage the intelligence we've already been building to build up and reinforce our cover. It's also our opportunity to account for any limitations we might need to explain to an adversary. So, maybe our budget is really limited, so it's going to be a very small environment. We can construct our cover story to take that into account. So I'm not going to go through every single thing that Turla does here, so don't have time, but I'm going to get a couple examples of looking at specific tactics with an attack and things that we might be able to infer from that. So all of the initial access that we have in attack for Turla, we see them doing various forms of spear phishing. And so we can probably infer from this, at least in cases where they're doing this, that Turla is expecting email and end user systems. If you're expecting somebody to click, they've got to get the email. And in most cases with spear phishing, there has to be a user able to actually interact with it. So discovery is where we also get a lot of our information on what an adversary is looking for. And so there's not a ton here for Turla specifically. Something we can see here, if we start to look at it, is that they're doing a number of techniques that are looking for remote systems in the network. And so we might be able to infer that Turla is expecting multiple systems. Yeah, so it's, don't have a ton to work off from this. So as we take this together, we can start to build up a cover story. This example, so say I've decided my cover story is that I'm the ACME Corporation. That's a small subsidiary of another company located in Zurich, Switzerland. Has a dozen users, each with their own Windows desktop. It's all sitting on a domain. They're connected to each other. This company has its own email and file servers, et cetera, et cetera, et cetera. And so this isn't the story I get to tell the adversary, but what I will then fit the rest of my deception into. So this little story tries to account for the fact that we might have a limited budget. So, why is it that we've only got a small number of systems and this isn't just some big gargantuan enterprise? It also tries to meet the expectations that we think the adversary might have. So expectations of multiple systems, having email accounts, as well as there being end user systems with people logged into them. So now we need to use that cover story and the information we've built up to start making deception decisions. We need to determine what needs to be hidden and then revealed to the adversary. So I like to think of the adversary's point of view as similar to a camera in a movie set. The adversary has a very limited vantage point. They can only see very specific things, and they've got the camera angles and view that they can only see from. They aren't able to see behind the walls. They don't know that there's scaffolding back there. They're not omniscient. And so we need to make the decisions of what the facade looks like and what we're hiding behind it from the adversary's point of view. So in order to do that, I'm going to use another classic deception denial planning technique. So this is a deception denial methods matrix. And I've actually taken some example deception denial techniques to start with, again, from Cyber Deception Denial and Counter Deception. It's a book published by a group of MITRE authors. So we've got two types of deception objects that we're going to be working with. We've got our facts and we've got our fictions. So these are our truths and our lies. And then we've got two different decisions we can make with them. We can reveal them or we can conceal them. And most things in the deception planning space, in classic deception, tend to fall into revealing fictions and concealing facts. Well, there is types of things we can do that actually fit into all four quadrants. So for revealing facts, we might decide that our adversary probably already knows our network information. They can look it up on ARIN, they know our IP space. And so we might use our true network info in our operation. So, our real IP space. We might include some real files in there. We may want to determine that we want to reinforce the deception by actually giving them some real information we're willing to let the adversary have. Or we might selectively remediate. So we might let the adversary see us do some of our defensive measures in order to see how they would react to them in the real world. We can reveal specific fictions to them too. We can show them some of our deception. So we might want to misinterpret the intent of a piece of software. So maybe there's a logging tool that we want to show them by having it hide in plain sight. We want to rename it in the process listing. Maybe we want to expose fictional systems, so other remote systems that an adversary might be able to use. Maybe we want to disclose fictional information, whether it's fake documents, bookmarks, users, etc. There's some facts we're going to want to hide as well. So, we might be doing collection on these end systems that's beyond what you might find on a normal enterprise computer. So we might need to hide that collection software, or the connections of that collection software to other places. We might want to hide some of the real environment or real resources. Maybe we don't want the adversary pivoting from capability into other parts of the network. And then conceal fictions is generally the sort of the close to empty part of a denial and deception matrix. And so we may want to hide some of the simulators we're doing, or just look at our overall OPSEC picture of actually hiding the deception. So if I go back to our discovery techniques, I'm going to look at a couple example techniques that we might be able to draw some decisions for this denial and deception matrix from. So let's start with remote system discovery. So remote system discovery is that you have an adversary in your network. They're looking for other systems within that same network, in a lot of cases in order to do lateral movement into. And so seeing that we've got an adversary that's doing remote system discovery, we might decide that we want to reveal the fiction that there are other fake systems on the network. Maybe we decide we want remote system discovery to succeed. And so they're doing this looking for other systems. Maybe the system that we're gathering information from on our deception hosts, well, maybe we don't want them to find that with remote system discovery. So we're going to conceal the fact of our collection system. So let's pick on another technique. So system network connection discovery. System network connection discovery is an adversary on a local system looking for existing cached connections to other computers. So this may lead us to want to reveal some specific facts, reveal a specific fiction. So maybe we want this to actually show a connection to a target host. Maybe we want them to succeed, feel better about themselves, and maybe see a pathway to that other system. And similarly, we may want to conceal a fact here. If we've got a long-running TCP connection to our logging system, this might be something we want to hide. And I'm not going to go through every single technique that we're seeing Turla do in the interest of time, but just augmenting some of these example techniques with some of the techniques we're building up from looking at the things that Turla is actually doing. So finally, it's time to design and build the technical capability. What we're doing here is basically implementing what we've decided to do in the denial and deception matrix and doing it in line with that cover story that we've created. We're going to design and build the different facts and fictions that we've said we're going to show the adversary. And we need to build concealment around what we've decided we're going to deny to the adversary. Throughout this, it's probably good to get into the procedure level of how an adversary is actually operating, to take a farther look at meeting expectations and making sure that what we're designing actually matches up with the adversary. So I mentioned remote system discovery. So going into the procedure for Turla using remote system discovery and attack, we see that what they're actually doing is using the netview and netview domain commands. Okay, so we've decided that the fiction we want to reveal is that we want to expose fake systems on the network. And so we can also make the assumption that, at least in some cases, Turla probably expects netview and netview domain to work. And we can start to make design decisions from it. So netview and netview domain are generally just looking for Windows systems. They're looking for things that are being seen through cache browser behavior. And so we might want to put fake Windows systems in the network to be seen in this. Now, if we want to make sure these work, we actually may need to do design to make sure that the fake systems show up in netview. Interesting tidbit, a Windows domain built from scratch, netview often doesn't do anything, whereas in a legacy domain, there are different services turned on where it has a different effect. So also using the system network connections discovery that we mentioned before. So the specific thing that Turla is doing here is looking at netstat, looking at netuse, and a bunch of different net commands, as well as a API call to directly see current TCP connections. So we decided that we wanted to create connections to target host while hiding connections to a logging system for this. And Turla seems to expect some number of these to work, to actually see things, so they probably wouldn't be doing it. So we can make some decisions on how we want to reinforce this. So I'm going to decide, in line with us creating Windows hosts on the network, we're going to create standing connections using netuse. So this will create something that netuse will see. And then to hide connections to the logging system. So looking at this, we've got things that will see long-standing TCP connections. So maybe we want to leverage UDP for logging and stay invisible to the actor. So once we've gone through all of our denial and deception capabilities, actually come up with implementations of them, it's finally time to deploy it. Now, if our goal here is deception for detection, we're putting something out there, deploying it, turning it on, and then waiting for an alert. So it's something that's going to probably sit out there for long periods of time, waiting for something to happen. If our goal was deception for intelligence gathering, we're probably putting it up and then waiting for an opportunity, waiting for an adversary to do something where we can actually start gathering intelligence. And then finally, let's get more intelligence. So, whatever we're putting out there, we're gathering some type of intelligence, and there are a lot of different types out there. And so you might have been thinking to yourself, hey, I don't think I've ever seen a presentation from somebody on the attack team that doesn't include a pyramid of pain. Well, we saved it for the end. So you can look for things all the way up and down the pyramid coming from an adversary. And so a little bit outside the pyramid, you might be just looking for adversary presence, so a tripwire. And so building in some sort of detection alerting capability. We can also start to fill in more of the attack matrix in terms of techniques used by adversaries. And this might be techniques that we've already gotten attack, and it might be techniques that we haven't seen in the wild yet, and so that you're creating your own techniques. But the way you actually are monitoring for this is probably going to look very similar to the way you do defensive measures looking for attack techniques today. Some combination of host and network monitoring, watching the system, and if you're really lucky, command and control decoding, so you can basically look over the adversary's shoulder. So we talk about indicators of compromise often as sort of being at the bottom of the pyramid, but fresh files, IPs, and host names are absolutely valuable. May not be as valuable for long-term use as behaviors and TTPs, but they're absolutely something to gather from adversaries, especially if you're getting them while an adversary is using them. So we've got this intelligence, and we want to use it. As we're gathering intelligence, we want to improve our profile, adding techniques to it, adding procedures to it, understanding better what our adversary is doing. If we see the reactions, it can help us strengthen those inferences. As we build it, we want to use that to reinforce and update our cover story and deception matrix decisions. Continue to operate, gather more intelligence, and keep going. This is the process I've just been going through, looking at how you can go all the way from starting with understanding your adversaries, working with threat intelligence, all the way through to gathering intelligence. And so this is leveraging a lot of the traditional deception techniques to work in the cyber realm. So some of the techniques, takeaways that I'd hope that you'd get from this is that we can apply practices from historical deception planning, cyber deception. We don't need to do it completely differently. See it as a intel devoid space. That intelligence can play a critical role throughout the planning and operation of cyber deception. And from an attack perspective, hopefully people see that there are other things you can do with attack besides just traditional defensive practices. With that, I'm happy to answer any questions that people have.